All right, so this is the answer key for 6-1. Apply what you have learned. So looking at the first one, name the regular polygon that has an exterior angle measure of 24. And so we know that that's our 360 divided by n. And if we solve that, that's going to give us n equals 15, which is a 15 gone. B, name the regular polygon that has an interior angle measuring 135 degrees. So 135, here's our expression over here. When we solve that, we're going to get n equals 8, which is an octagon. Here in yellow, I've translated the sum of the measures of the interior angles. Is in red is our equal sign. 3 times the sum of the measures of exterior angles in green. When you solve that, you should get n equals 8 for octagon. If we look at the next one here, we're trying to find these angle measures that have letters. If I look here, a couple of different ways I can start, but things that you might see. Here we have a triangle sum. If this is an isosceles triangles, these base angles have to be the same. So we take 180, subtract 26, and divide that by 2. That gives us 77 and 77. Then we know that these two and these two are linear pairs, so they have to make a 180. So this is 103 and 103. Over here, we find out that this is 97 was given to us. This has to be 83 to make 180. If these two lines are parallel, like they're marked off to be, then I know that the alternate interior angles are going to be the same, and that's how I will know 83 and 97. And then the last one I would be missing is A, and so if I take and I count up the sides, 1, 2, 3, 4, 5, then I know that that's a pentagon, and it's 540 for the sum of the interior angles, and I subtract out the 103, the 97, the 83, the 154, and that'll give me the 103. Over here, we look at this, and if I know that if this is 100, this has to be 80. If these two angles are congruent, then these two angles must also be congruent. So I take 180 minus 80, get 100. Each one of these have to be 50. So therefore, each one of these have to be 130. If this is 40, this has to be 140 to make 180. And then if I look at this 1, 2, 3, 4, 5, 6, that gives me 7. That gives me 900 for the interior angle. So if I take that 900 and I start here and I subtract out the 140 and the 130 and the 130 and the 135, I'm going to get 365, and there are 3 remaining. 1, 2, 3. If I divide those by 3, each one of those is going to be 121.7 approximately. Let me take and move this up. And if we start here to look at number 2, remember that the sum of the exterior angles is always 360. So I knew this was 72, so I could mark that as 180. If this was 134, I knew this was 46. This was 82. I knew that that was going to be 78. If I look at the rest here of the exteriors, my exteriors are x, 2x, 3x, 72, 46, and 98. If you set those equal to 360 and solve, you get that x is 24. Once you get that x is 24, this one is 2 times 24, 48. This one is 3 times 24, 72. And then you can use the supplementary to make sure that you can get that angle, the linear pair, with the A, B, and the C. Last one on this page, If this is an equilateral triangle, each one of these is 60, so I knew that was 60. This is a square, so this is a 90. This one is 1, 2, 3, 4, 5, so that's a pentagon. And if I take and divide that out, that's going to be 105 for each one of those. So then I've got 360 minus 60 minus 90 minus 105. That gives me that angle is 162 there. Down here, if this is 90 and this is 175, this angle must be 162 to make 360. But if I look at this triangle sum here, I know that I have to have 180. That leaves me 18 left over. 9 will go here, 9 will go there. I know that because it's marked off as an isosceles. Right, go on to the next page. Find the sum of the measures of the interior angles of a convex 13gon. So n minus 2 gives me an 11 times 180, which is 1,980 degrees. Find the interior measure of one angle of a regular octagon. So 180 times n minus 2 divided by n is going to give us 135 degrees. Name the regular polygon that has an exterior measure of 30 degrees. So measure 360 divided by n, that gives us 12, which is a dodecagon. Name the regular polygon where the sum of the measures of the interior angles is 3,960. So there's our sum, and 180 times n minus 2, which gives us n equals 24 when we solve it, and that's a 24gon. Find the interior measure of one exterior angle of a regular heptagon, so that's 360 divided by 7, approximately 51.4 degrees. Number 10, if the measure of an exterior angle of a regular polygon is 157.5, name the polygon. So here's our expression. When we solve that, that gives us n equals 16, and that's going to be a 16gon. If the sum of the measures of an interior angles of a polygon, that's this, equals the sum of the exterior angles, that's this, name the polygon, n equals 4, which is a quadrilateral. If the sum of the measures of the interior angles of a polygon, that's this, is twice the sum of its exterior angles, that's this, n equals 16, that's a hexagon.